Um, we'll discuss today the structure questions related to topic light as we discuss multiple choice questions. Okay, in this question, this is mainly related to light. So the reason to discuss this topic is so that you have an understanding what you have studied till now, how the question will come related to the topic. A ray of a light passing through a length of curved optical fiber or fiber optic. Draw a diagram, show the fiber and the path of the ray. So you have to draw a curved optical fiber. You can make one bend or you can make more than one bend. You can make it like this, or you can just make one curve just because you want to explain the idea that how it allow the light to pass through. So what happened, how you represent this, because in optical fiber or fiber optic, light will undergo total internal reflection. What is total internal reflection? When angle of incidence is more than critical angle, instead of light will refract, means go out from the surface, it will bend or reflected back in the same medium, we call total. So if when the light strike, this angle is more than the critical angle, light should go out because it's a transparent material, but light will not go out, it will reflect back in the same medium. When again it is strike, angle of incidence more than critical angle, so it will undergo total internal reflection. This is fiber optic or optical fiber. And this one is a ray of light. So that you have to draw and you will score 1 mark. Describe one use of optical fiber in medicine. So optical fiber or fiber optics, it is used in a technique which we call endoscopy. How it works, how it is used in this endoscopy. So basically what happened, the light travel through optical fiber, and we use normally bundles of optical fiber so that it can bend. So light travel through optical fibers in and out. That's one thing. Then what happened? It will make to examine the internal organs. And this technique is known as endoscopy. So first thing, you can mention the name of the technique, use endoscopy. And then light travel through optical fiber into and out of the body, and it is used to examine the internal organs. Is it clear? The reason why more space is there, like some student want to elaborate, write in detail. So you can write the detail about it if you want to. The points which will score, you will score or get the mark. One is mentioning the technique, endoscopy. You may draw a diagram. If a question is optional, like if they say you may draw a diagram, it's better you try to draw a diagram. Reason for that may be If your answer is not complete, maybe your answer is not complete, so your figure or a diagram will give you mark. Is it clear, this question? Any doubt in this? Okay, next question. Draw a straight line from each wave on left to the most appropriate speed. Light in air. What is speed of light in air? Which one? First, second, third, fourth, fifth, sixth. What is speed of light in air? The fifth one, the speed of a light. That's 3 exponent 8. What is the speed of microwave in a vacuum? Microwaves are all electromagnetic waves. Light is electromagnetic. Microwaves are also electromagnetic. So they all travel with the same speed. So what will be the speed of the microwave? That also 3 exponent 8. And what is the sound, speed of a sound in steel or speed of a sound in solid? So speed of a sound or speed of sound in solid about 5,000. So the closer value is 6,000. That's why I mentioned 6,000 here. These are approximate speeds, appropriate speed according to the question. Yes, any question? The next part, how we will know this, as we discuss the speed of a sound in 3 mediums. For the sound in air, it travel around 330 meter per second. 330 to 340. Even you can write 300, that's acceptable. That is in gas. Air is there means gas. If there's a liquid, approximate speed of a sound in a liquid is about 1,500 in liquid. And for solid, it's about 5,000 meter per second in solid. So steel is a solid, so means it should be in this order. So which of the option is in 5,000, range of 5,000? So this is too small. This is 100,000. So these are all are too high.
The speed.
You have to memorize the speed of sound. Speed of sound in air, or means gas, solid or liquid. So you are left with only one option. That's approximately 6,000. And you have to learn the speed of all electromagnetic wave, which is 3 exponent 8 in vacuum. And in air, it is a bit smaller, means slower than compared to vacuum, but negligible change as compared to vacuum. So approximate is about same as in vacuum. In the next part, the refractive index is 1.5. Use the value, calculate speed of a light in a block. So the formula which relate refractive index and speed, refractive index is equals to speed of light in air or vacuum divided by speed of light in a medium. Means which medium, like example glass, water, which medium it is traveling. So refractive index denoted by n, speed of a light in air, that's 3 into 10 power 8 divided by speed of a light in medium is v. So we need v. Refractive index is given 1.5. Refractive index does not have any unit because it is a ratio. So we can say 1.5 is equals to 3 into 10 power 8 divided by v. V is divided, other side multiply. So v is equals to 3 into 10 power 8 divided by 1.5. So 3 exponent 8 divided by 1.5. So v is equals to 2 exponent 8 meter per second. Why I solve 2 exponent 8? Because 3 divided by 1.5 is 2. So I wrote 2 and exponent 8 is already there. Is it clear? The speed of the light in the block, and it is obvious it should be smaller value as compared to that in air. Okay. Next question. Figure 6.1 shows a protractor superimposed on a path of a ray of light. The light is traveling in a glass towards the boundary with air. Use a protractor, measure the angle of incidence. So what is the angle of incidence? Angle of incidence is always from normal to the ray. So what I can do, this is a normal, the perpendicular. I'll use another color so you can distinguish. So this red line is representing a normal. We need this angle. So what is this angle? How you can find? Look, the ray which is coming, the incident ray, this one is the incident ray.
35 degrees.
Yes, from 0 to this point is 55. So from 55 to 90, that's 35. So we always measure angle from normal. 55 is not the angle of incidence. 35 is the angle of incidence. Yeah, 35 degrees. That is the angle of incidence. The refractive index of a glass is 1.6. Calculate angle of refraction. So it is moving from, in the question, it is moving from glass to air. When the light travels from glass to air, the formula for refractive index, it's sine angle R over sine angle I. So whenever it is traveling from high density to low density medium, or here glass to air, the formula for refractive index N equals sine R divided by sine I. So we have to use, just substitute the values. Refractive index is 1.56. So 1.56. Sine R we don't know. And sine I we already have. We just solved the previous part, which is 35. Sine 35 is divided, other side it will be multiplied. So 1.56 multiplied by sine 35. What is the answer for this? 1.56 multiplied by sine 35. Use a scientific calculator. It is 0.89. Okay. So when you multiply, it's 0.89. So 0.89 is equals to sine r. But you don't need sine r, you need only r. So if you need r, when sine will move to other side, it will become sine inverse. So sine inverse 0.89. What is the answer? Sine inverse, shift sine inverse 62.9. So the angle will be, and keep in mind, whenever you're solving a question, um, the calculator mod should be in degrees, because calculator can take a mod in angle in radian. So if, for example, if you forgot to change your calculator mod to degrees, and if it was in radian, and you will solve this question, so you will get a wrong answer. So just keep in mind, whenever you're solving a question, always check the mod of your calculator. It should always be in degrees. Radian and degrees are the unit of angle. Angle can be in radian, angle can be in degree. These are the units for angle. But you're solving, all these angles are in degrees. So when what I'm saying, when you solve, your calculator screen should be in degree, mod degree, not radian. Degree, it is written DEG, or we represent DEG, but in a calculator you will write, or you will find D is there. So the reason why I'm repeating this, because this happened with one of the student. He solved question correctly, but he forgot to change, not decrease, degree. So angle should be in degree. So what we'll get 62.9 degrees here. What is meant by critical angle? So definition of a critical angle, what is the meaning? It is angle of incidence known as critical angle when angle of refraction is 90. So angle of incidence is also known as critical angle when angle of refraction is 90. In this question, a block is made from a particular type of a glass. Figure 6.1 shows a light passing from air to glass. Use the information, find the refractive index of the glass. What is the angle of incidence here? What is the value of angle of incidence? And what is angle of refraction? The angle of incidence is how much? Angle of incidence. Angle of incidence is actually 61, not 29. Because angle of incidence means the angle between the normal and the incident. The total angle is 90. So between surface and the ray is 29. So angle of incidence is 61. And angle of refraction, angle of incidence is 61 and angle of refraction is 33. In this example, light is moving from air to glass. So when the light travels from air to glass, it means it will be sine I divided by sine R. So sine angle of incidence is 61 divided by angle of refraction 33. What's the answer? Sine 61 divided by sine 33. It's not 61 divided by, it's sine 61 divided by
1.6.
1.6. And what will be the unit? 1.6 meter, centimeter, degree. What is the unit?
Degrees per centimeter.
There is no unit because it's a ratio. It's just a ratio, means compared to air. What is the meaning of 1.6? Means compared to air, this glass having a tendency to bend light 1.6 times more than air. That's the meaning of 1.6. It's a comparison, like ratio. Compared to air, this can bend the light 1.6 times more. So refractive index does not have any unit. The critical angle, how to find a critical angle? So how you can, as you know, the formula which relate, because critical angle is when the light is moving from denser medium to rarer medium. So formula which relate critical angle and refractive index is n is equals to 1 over sine c. C means critical angle. This is a formula which relate angle of incidence is also known as critical angle when angle of refraction is 90. So a simple formula which relate critical angle and refractive index, n is 1 over sine c. So already we worked out the refractive index which was 1.6. So this is 1.6 equal 1 divided by sine c. So cross multiply sine c is equals to 1 divided by 1.6. What's the answer? 1 divided by 1.6. 1 divided by 1.6. What's the answer?
0.625.
0.625, and take a sine inverse of 0.625 because we need critical angle or C. So C is equals to sine inverse
38.6. 38.7.
38.6. No need to round off the angles because even a small angle make a difference. So if it is like 38.7, write 38.7. So this will be 38 point. Like no need to write 39, you can write 38.7 because a small, even a 0.1 degree in angle make a difference. Write always answer in 3 significant figures. Always accurate answer in 3 significant figures. Use one application of state one application of optical fiber and draw a diagram how an optical fiber used in this application. So it's up to you as we discuss. Sine C means critical angle. Look, you have the formula refractive index when the light moving from denser to rarer. So it is sine angle R over sine angle I. This angle I is also known as a critical angle when angle I is known as a critical angle when angle of refraction is 90. And when you put sine 90 in on your calculator, you will find sine 90 is equals to 1. So that's why I just directly wrote the formula n is equals to 1 over sine c. You can use this formula and find the angle of incidence that will be the same as critical angle. Yeah, you can mention endoscopy, or you can also mention for communication like internet communication we can use. So you can mention a relevant diagram according to that. Rather than telephone wires nowadays, internet are used, like internet communication. Telephone wires also nowadays are replaced by optical fiber or fiber optic. So what happened, how it occur? When you are making a phone call, actually your information is converted in the form of light. and this light will travel through optical fiber, undergo total internal reflection, and received by the person you are trying to call, and you can communicate. So you can either mention medical use or communication through wire or endoscopy. In question 4, a ray of a light in a glass is incident on a boundary. What happens when the ray angle of incidence is less than the critical angle? If the angle of incidence is smaller than the critical angle, like if I say this is a surface and this angle at which the light strikes, this angle of incidence is smaller than, say the critical angle is 40, okay? This is just an example, and the light strike at an angle example of 20. If it is less than critical angle or smaller than critical angle, so if it is less than critical angle, then only refraction will occur. Means partial reflection and refraction is there, but most of the light is refracted. So if less than critical angle, then refraction will occur. If it is greater than critical angle, then no refraction. All the light will reflect. So here you can also mention a small refraction and some reflection or partial reflection. Means some of the light will reflect as well. Not all, but some of the light. But if it is more than critical angle, all of the light will reflect. No refraction occur. We call that as total internal reflection. In the second part, figure 6.1 shows a ray of an incident on a glass. The critical angle is 41. Okay. They mention a critical angle as 41. On a figure without calculation, you don't have to do calculation. Continue the ray from point B until it leaves the glass block. So I want to complete the ray. So what I will do, I will draw a normal here. So when I draw the normal, what is the angle of incidence in this? What is the angle of incidence here at point B? So angle of incidence is 60. If angle of incidence is 60 and the critical angle is 41, what we will observe? Angle of incidence, so it will refract or total inter-reflection? Angle of incidence is more than, you can see here, angle of incidence is 60 and the critical angle is 41. Angle of incidence is more than critical angle. What will happen? It will undergo total internal reflection. It will not refract. No refraction occur, because critical angle means angle at which the light will travel with 90. If the angle is more than the critical angle, then only light, what happen? Light will reflect. No refraction occur. The light will reflect. So it will hit this point. When it will hit this point, again you will draw the normal. What is this angle now? at this point, example, if I label this point as C, what is the angle of incidence? What is this angle? This was 60. What will be this angle? In mathematics, you used to solve a question related to these angles. This angle will be 30. So at this point, the angle of incidence at point B. So what happened at B? The angle of incidence was 60, which is more than critical angle. That is why total internal reflection. But what happened at C? Angle of incidence is equals to 30. So and critical angle is 41. So which is smaller than critical angle. So only refraction will occur. So what happened? Only a refraction will occur. It will just bend away from the normal, or it will go out from the surface, moving from glass to air. So this is a passage or the path. It's without calculation, just your idea or understanding you have to use. Now calculate a refractive index. How to calculate a refractive index? If we know the critical angle. So if you know the critical angle, the formula refractive index is 1 over sine C. So refractive index we don't know, and critical angle is 41. So sine 41. What is the answer? 1 divided by sine 41. What's the answer? 1 by sine 41. 1.52. And what is the unit? Yeah, so it does not have any unit. Okay, another question. A speed of a light in air is 3 exponent 8, and speed of a light in a transparent liquid is 2 exponent 8. Find the refractive index. So how to find a refractive index? Refractive index is equals to speed of a light in air. You have to memorize this value. Some question they give you this, some questions you don't have speed of a light in air, so you have to memorize speed in medium. The refractive index, speed of a light, it's 3 exponent 8 divided by 2 exponent 8. So exponent 8 can cancel with exponent 8, and 3 divided by 2 is 1.5. So you will get 1.5 as an answer. Then angle of refraction, a ray incident on a surface of a liquid at an angle of 40. So it's moving from air to the liquid. So moving from air to liquid or air to glass, the formula for refractive index is n is equals to sine I over sine R. And they mention the ray incident on a surface at an angle of incidence 40. So angle of incidence is given 40. Refractive index you already worked out in the previous part, 1.5. This is sine 40 over sine R. So cross multiply sine R is equals to sine 40 divided by 1.5. What's the answer for sine 40 divided by 1.5? It's 0.42, and take a sine inverse of 0.42. So it is 24.8 degrees, because R is equals to sine inverse 0.42. You'll get the answer. So 24.8 degrees. Okay. Figure 7.1. So figure 7.1 shows a side view of an object which is inside a bottom of the tank. Light travels slower in the liquid than in air. On the figure, draw two rays from object into the air and use to locate the image. So how you locate the image? So what happened as we discussed this, the objects appear to be closer. So when the light travel from air, liquid to air, it will bend away from the normal. So two light rays which are coming out, they bend away from the normal. So what our brain sense the light is coming straight from the object. So when our brain relocate the position, so the point where our brain make these line intersect, that is the position where we'll get the image. That is why, like example, a swimming pool, in reality it is deep, but it appear to be shallow due to refraction of the light from the bottom. Is it clear? So light moving from liquid to air, they bend away from normal, enter our eye, our brain always sense light is coming straight from the object. So when our brain relocate, it create an image, the point where the two light rays will intersect. Is this image a real or virtual? What kind of image is this? Real or virtual? This is virtual or imaginary image, because in reality it's not there. It is only our brain relocate and create an image for us. That's why it is called a virtual image. So these are few questions related to topic light. Now we'll do some question related to lens topic. The next session I will complete the lens topic with you. Lens and mirrors.